Hi everyone and welcome back to Mossy Maths GCSE. Today we're going to be going through the final lesson on the topic of trigonometry, which looks at the area of a triangle, which is not necessarily a right angled one, so we use a different rule. And in this case we use this rule at the top, area equals a half AB sine C. Now again, this is for the higher tier GCSE students, so we're going to go through two examples, and then we're just going to go through a quick review of the previous 4 lessons on trigonometry, just going through simply the answers to these questions. If you do want any more information about the working, then the best thing to do will be to go back and watch these previous lessons, because these are just going to be some examples you can try at home, and I'll just give you the answers to these questions. So for the first two, we're told calculate the area of the triangle to 3 significant figures. That's for this question here. So the area is a half AB sine C. Now A and B just represent the two sides next to the included angle. Now remember, the word included just means the angle in between two sides, the angle wedged in between, in this case C. So it doesn't matter which one we use as A and B. I'm going to use this as A and this as B for the sake of the opposite side being the lowercase letter. So in this case we'll have area equals 0.5 times A, 5.2, times B, 7.1, times the sine of the angle, which is in this case 42. And all we do is type that into the calculator. So we get 0.5 times 5.2 times 7.1 times the sine of 42, and we get 12.4 centimetres to 3 significant figures. Now the next one, the area of the triangle is 5.45 centimetres squared. Find the perimeter to 3 significant figures. So this is a more challenging example. We're looking at 4 to 5 marks in an exam for this. What we need to do is figure out how we can work out the perimeter. Now the perimeter is just all the sides added together. We have 2 of them, we need to work out this one. We can't apply the sine rule, and we can't initially apply the cosine rule because we don't have the angle. But we have the area, so let's write down the formula for the area. Area equals a half AB sine C. And the only thing we don't have here is the included angle. We have the area, it's given to us in the question. We have A and we have B. We have the 2 lengths next to this included angle, but we don't have C. We could rearrange this, however, to work out the sine of C, and therefore find out the value of the angle. So all we do is do the area divided by this, because remember this is all multiplied together. So if we do the area divided by a half AB, this will be sine C. Okay? So sine C is equal to area, which is 5.45 centimetres, divided by 0.5 times A, doesn't matter which one we use as A, I'm going to use 3.2, and 5.3 is B. Now C is therefore sine to the minus 1 of the answer we get to this. Now for this what we get is 5.45 divided by 8.48. So we get 0.643 to 3 significant figures. Now remember, don't round this before. Keep the whole number in your calculator. I'm going to write this because it's saving space on the board, but in the exam, leave the whole answer that you get and do the inverse sign of that answer because you don't want to lose accuracy. And doing that we get C to B 39.99 to 4 significant figures, and again remember this isn't the answer, this is just our value of C, which in this case is X. Okay, so just write equals X to make sure the examiner knows you've worked out this angle, or write it on the diagram in fact. 39.99 degrees to 4 significant figures, but remember we want to leave the whole value in our calculator when we do the next calculation, because the next thing we have to do is work out this length. Hopefully you can see we're going to apply the cosine rule. The cosine rule can be applied when we have an included angle and 2 sides. We've worked out the angle, so A squared, which in this case is YZ squared, equals B squared plus C squared, so it's 3.2 squared plus 5.3 squared, minus, and I'll put this in brackets, 2 times 3.2 times 5.3 times the cosine of the angle, which we've just worked out to be 39.99 degrees. If you're not sure, do go back and watch this lesson. It's a previous video on the cosine rule and sine rules. So A squared just typing this whole thing in, I'd work this out first, then subtract this from this. So we get cos of the angle times 5.3 times 3.2 times 2. That gives us this bit, which is 25.98. And we're doing 3.2 squared plus 5.3 squared minus that answer we just got. So a squared is 12.34. Remember to leave the whole thing in your calculator. I'm just rounding it for the sake of saving space. And a is therefore the square root of 12.34, which is 3.513 and some more numbers. And that, remember, is this length here, which equals yz. Okay, so now we have this length, and this length. We've not finished, we need to work out the perimeter, so we just add them all together. So perimeter, I'm just going to shorten it to PER, equals 3.2 plus 5.3 plus the side we just worked out, 3.513, and leave the whole thing in your calculator. And adding them together we get 12.0 to 3 significant figures. Centimetres. There we go. So that would be full marks. Now this is just a review, so pause the video, have a go at each of these questions, and then I'm going to quickly give you the answers to them to make sure you've understood the previous lessons. Okay, so the first one, we should get an answer of 32.98 centimetres as x. If you're doing it to 4 significant figures, well that's just 33.0 to 3 significant figures. The second one, 7.81 metres equals e to c, which is this here. This one says draw a graph of y equals cos x. So remember, cos x starts at 1, goes through 90, down to minus 1 at 180, then back up like this. So this should be the shape of the graph we get. Not entirely accurate. Then if it's equal to 0.75, the way we'd work this out is we'd draw a line across at 0.75 to the curve, then down to the x-axis and read off this value. Then for the final one, find x. What you should have got for this using the sine rule is 7.96 centimetres to 3 significant figures as our value of x. So thanks a lot for watching the video. That was a quick review and a lesson covering the area of triangles, which are not necessarily right angled ones, using the area rule, which involves using the sine function. This is for the higher tier GCSE paper. So if you found the video helpful, please do leave a like. If you have any questions, then feel free to put them down in the comment section, and I'll try and get back to you as quickly as I can with a response. And if you haven't already, please do subscribe to my channel. So thanks a lot, and I'll see you in the next lesson.